where we've been fitting and what our model is, right? So it's wastewater treatment as a service. It's a distributed approach. We plug and play on a customer site. Our first customer was PepsiCo. At that particular bottling facility, we've been saving up to a net 30% for them on their sewer bill relative to what they were doing before. And we're mitigating over 100 tons of greenhouse gas emissions every single month. And that's because of the energy efficient approach that we take to treatment. And all of that organic carbon is not going down the drain to a centralized facility, which is powered by coal right now. And so that's really where the mitigation comes in, is treating these very high loads, high intensity concentration wastes, but in a very sustainable, energy efficient way.
Welcome to Distilled, brought to you by Catium. I'm your host, Will Sarni, founder and CEO of Water Foundry, founder and general partner of Water Foundry Ventures. During each episode, we'll speak to global water leaders doing their part to solve wicked water problems. We'll talk about their career, their perspective on the water sector, and what might come next. So I'm excited to have our guest on this episode, a friend and colleague and dare I say fellow troublemaker in the world of water. You're smiling, that's good. The founder and CEO of Aquacycl, Orianna Bretschger. And I know I kill your name every time I say it, but if I say it enough, I'll get it better. So Orianna, thanks so much for being on this episode.
Hi, Will. Thank you so much for having me. It's a pleasure to be here.
There's so much to discuss. You and the team at Aquacycl are really doing impressive things. So really want to talk about your career. I looked at your CV. It took me about an hour to go through it. Really impressive.
It's double spaced.
It's just this epic journey. So tell me the beginning. How did you get started in your career, and some of the pivots that you've made along the way? I mean, not pivots into strange new worlds, but how did you wind up in the world of water, considering your background and education and so on?
Yeah, well, it was a meandering path, but one I'm very happy to have taken. So I grew up in the rural southwestern United States. So I was actually born in Oregon, but mostly raised in high deserts in Arizona and New Mexico, and very rural parts of the states. So water was always, a big consideration in our daily lives, and that's impactful. So it's always been with me as an important element. But I've always been a nerd, and I love science and technology and engineering, and so pursued a path, of science in my education, and did a little stint in aerospace and some government consulting, and realized that wasn't my passion. And then I made my way to Southern California for graduate school. And it was there in 2004 at the University of Southern California that I was able to reconnect with water and developing a technology, really. At that point, it was really much more of a fundamental science journey and understanding of how we can use microbiology as a way to accelerate water treatment, but controlled electronically, which is very different than how wastewater treatment and most microbial systems are controlled. And so this was inspiring to me, and it was also totally by accident. So I started my PhD in the material science department, so engineering, and I had there was a visiting professor that came to talk to our cohort about these microbes that have a capacity to breathe rocks and generate electricity and do all of these incredible things. And so my mind was blown. Um, and I literally did go to his office the next day and beg him to take me as a student in his laboratory, even though he was in biology and in the earth sciences department. So the engineering school and the earth sciences cohort worked it out, and I did most of my research in his lab. Finished with an engineering degree, but that's really what kicked this whole thing off for me. Is really understanding, how microbes electronically communicate with the environment and with each other. And it's just a movement of electrons that facilitates a breath, and that we can essentially control that breath, right, by just applying a resistor across the circuit, which in effect also controls metabolism. So the technology that we developed, right, utilizes this function as a way to treat wastewater very rapidly and very precisely. And so that that really stuck with me. It was my passion, and I went to San Diego for a not-for-profit research institute, and another 8 years there in more of an academic setting, developing more understanding of the science behind these microbes, and then wrapping a technology around that that could be practical and applicable. So we spun out with Aquacycl in 2016, and I'm stuck in water now. I'm not leaving.
Well, you can't abandon us. I'm really fascinated by the technology, and I would say maybe even more fascinated by the business model that you've built over time. When you were sort of marrying up material science uh, and the electrical connectivity to microbes, was that sort of the beginning of that um, focus in terms of really understanding what was possible? It sounds like to me, and I consider myself a layperson in your world, um, that was probably pretty early on.
It was, yeah. Now we certainly weren't the first folks, to be researching this activity or this capacity. And a lot of research is still happening around the world in terms of how we can harness these reactions. Um, but at the time, 2004, it was kind of, there was a resurgence in this research field, um, with an understanding of how, what are the specific mechanisms that microbes are using to do this electron movement and breathe the rocks and make the electricity, right? And so as our scientific techniques got better with genomics and really understanding the specific mechanisms behind all of this, there was a lot more research that came around this understanding in the what's the fundamental mechanism. But what what most people were really focused on at the time was energy recovery. Like, okay, we're going to harness all of these electrons. Let's make a bunch of power, right? Let's the waste to energy concept. It was that was really where the focus was, and that's where the funding was as well. Um, but it's a biological system, right? And you can't ask a biological system to give up 100% of its energy. It's just it can't survive, right? And so I never really thought of it as a big power producing opportunity, but this ability to really control the metabolism, to have a very defined system, so you can you know let the bugs do what they do well, but not get away from you, which is often the problem in conventional wastewater treatment systems. I thought that was really impactful. And so, really, we've been focused on the water side of it. How can we make water treatment systems more efficient, more
Mhm.
energy efficient, smaller footprint, more active, just more consistent and reliable. So that's really where we focused. And then, because we're doing this in a distributed way, right? We're not focused on the big municipal treatment plants. God love them, right? But that's not where we're going to be a good fit.
Well, we'll come back to that one, Ellen.
But we can provide this service now, really, as a package plant, right? And we're doing wastewater treatment as a service. So it can de-risk, the opportunity for the customer that we're serving. We're maintaining and monitoring this remotely, right? So we don't need full-time people on site to run these things. So there's a lot of benefits that come out inherently from the technology, but that are an advantage, in terms of the value
Mhm.
proposition and business case.
It is one of the challenges getting the bugs, if you will, to respond in a consistent manner to the electrical, stimulus. Is that
Surprisingly, no. Um, there's a
really?
Yeah. Now, there's been a lot of work done around this. And it's been almost 20 years now, and I can say that. But what we do on site, so we're not starting with anything that's grown in the lab, right? When we take a piece of equipment to a customer site, um, there's no bug that has ever touched it, right? And what we do is we'll source material locally from drainage ditches, from lagoons. We're looking for sediments and sediments that have signatures of that are really smelly. If it smells like rotten eggs, we want it. Have a really nice dark black thick color because that's evidence of a biological activity for the bugs that we want. So we sample this sediment, right, and just literally like a bucket, right. We mix it with the wastewater that we want to treat, and then we bring all of that into the equipment, and all we're doing is creating an environment for the bugs to naturally set up shop, right, inside of each one of our reactors, our systems.
Mhm.
And they use those surfaces that they live on as a way not to live, but as a way to breathe. So we're encouraging the growth of these natural organisms, and we create an environment so bugs that do what we want them to do can outcompete the rest of the guys, and they stick around. There's an advantage for them. And actually, it doesn't matter where we're working in the world, right? We can source from freshwater, from saltwater, from brackish, like I said, drainage ditches, lagoons, wastewater treatment plants. Uh, it's very reproducible, even with lots of different wastewaters that we've tested.
I, I think there's like a whole body of work you could write on in terms of, these bugs are homegrown.
Yeah,
They're in their hood, and
exactly.
you're just helping them out. And they're not visiting. Right.
No, we want to encourage that subdevelopment to keep on going, um, but not overgrow. But not overgrow. That's critical.
Yeah, neighborhood bugs, and we help them out. I,
That's
I
right.
love it. That could be like part of your tagline going forward. Tell me about this leap from the academic world, doing very heavy research into, hey, yeah, why don't we go start a company? And you know, like, what was that like in the beginning?
Yeah, a leap is a very good word to use there. It was more like throwing ourselves off a cliff, but um, it well, it was a decision that was really sort of made for us. So yeah, when I was still at the not-for-profit, we had a foundation that was supporting my group, the Roddenberry Foundation. So the Star Trek
Oh, right.
family,
Sure.
and they were tremendous, and they saw potential for what this tech can do, really specifically in sanitation. And so they granted my team a $5 million grant to take what we had done in the laboratory and bring it out into the world and test it in the field. And so it was a 5-year award, and that actually started our first pilots. So we did a pilot in San Diego, California, with pig manure, and that's actually still running now, nearly 7 years later. And
Wow.
that same year, we also set up a system in Tijuana, Mexico, treating sewage sludge, and both systems worked very well. And so we spent all the money and we hit the milestones, and we came back to them and we said, okay, we have a couple options. We can continue to develop this under the not-for-profit umbrella, get it a little bit further, or potentially, we can jump out and see if this has an ability to be a self-sustaining business. And they said, go forth and make a business. And I said naively, okay. um, and they came on actually as our first investor. So they got us started with our first investment. They set it up as a match so we could encourage others to invest in the company as well. And through all of 2017, I was figuring out how to be an entrepreneur and no longer a scientist, and really how to craft our value, and understand what that really is. And we learned fairly quickly that it wasn't immediately going to be in sanitation. We're just at too much of a price point. It was too high to start there. But as we started our discovery journey, talking to a lot of folks in the industry, we learned that there's a good fit in industrial food and beverage manufacturing. And so we then have been understanding more and more about the challenges that that industry faces and other industries, and how our tech can uniquely provide value there.
I love that the Bradbury Foundation was involved. I had a chance to work with them when I did some work with the X Prize, and just
Yeah,
a iconic brand, and really thinking about shaping the future, and placing bets, and
yeah,
bets not in a negative way, but really
yeah.
believing in technology and people, and business strategy and so on. So I'm really thrilled to hear that. Uh, Tell me a little bit about your business model, and I want to hear about the 100 plus accelerator program, and how that worked out for you, and what you learned.
Sure, absolutely. Well, the reason that we're, in any of these programs is an amazing team. And specifically, we've got a marketing director that that really knows how to put an application together. Julie
and,
Iconello,
and,
I love you. Thank you.
and I agree with you.
um, so yeah, I think where we've been fitting and what our model is, right? So it's wastewater treatment as a service. It's a distributed approach. We plug and play on a customer site. Our first customer was PepsiCo, and so we've been commercial with them now for about 2.5 years. And over that course of time, we've really been able to demonstrate, what the tech can do and what the value is. So at that particular bottling facility, we've been saving up to a net 30% for them on their sewer bill, relative to what they were doing before. And we're mitigating over 100 tons of greenhouse gas emissions every
Mhm.
single month. And that's because of the energy efficient approach that we take to treatment. And all of that organic carbon is not going down the drain to a centralized facility, which is powered by coal right now. And so that's really where the mitigation comes in, is treating these very high loads, high intensity concentration wastes, but in a very sustainable, energy efficient way. And so when we first started, we really weren't tracking the climate impact of it. But then we started running the numbers and working with the California Energy Commission, and following some of the templates that they had laid out for, okay, how do you quantify mitigation and carbon capture, right? And so we're on the mitigation side. But when you start looking at all of the different contributors in the wastewater treatment scheme to climate, it's massive, right? And there's been
Mhm.
reports that have shown the way that we're treating our wastewater now, the wastewater accounts for about 70% of the total energy budget with water and wastewater treatment as an industry. Even though we're only really treating a fraction of what we generate daily, we're still we're still emitting more greenhouse gas emissions than the entire shipping industry. And that's probably not an accurate baseline. There was a report, Princeton University published a paper in February of this year that did a measurement of 63 different wastewater treatment plants across the United States, with direct measurements of emissions of their existing technology, which are almost all anaerobic digestion. Now, these 63 treatment plants only represent about 2% of the total volume that we treat in the US, right?
Mhm.
But the emissions were double what the IPCC had reported in
Wow.
2016. And so, we're probably underestimating as an industry our emissions by about 45%. And so
That's
if you think about it,
shocking.
yeah, right. And most of that is coming from leaky anaerobic digesters. Digesters are looked at as a great, waste to energy resource, and they can be, but they're really tricky to operate. And if you're not plugging every leak, which is difficult with a massive tank, you're going to see you're going to see these, unintentional emissions that happen, and that accounts for most of the emissions from a centralized facility. So the way that we're addressing that, one is bring that awareness to the forefront, right? If we really want to treat all of the waste that we generate, we can't keep doing it with these conventional
Mhm.
approaches and still meet our climate targets. And we're already seeing all of the I won't say all, but 95%, right, of climate related crises. It's because of water, too much or too little. And so we're,
Right.
you know, we are changing the world around us, but how we are treating water is is contributing to the problem. And so our goal as Aquacycle, right, is to provide a solution that is extremely energy efficient, which means you don't have all those emissions, and we don't make any biogas. That's not what we do. We make DC power, and um, and so bringing this story to the forefront with our customers, with PepsiCo, um, finally was sort of like, oh, okay, this can actually help us meet some of our scope 1, 2, 3 goals. And then bringing that to Anheuser-Busch with the 100 Plus Accelerator Program,
Mhm.
which was a tremendous opportunity for us to show, okay, what we can do in beer, also critical. Um, critical for human survival, I would say. Um, and so we had a successful trial with them, and now looking at commercial opportunities within that network. And what's lovely about that program is that they take a very very directed business case at this, right? It's not just okay, let's run a
Right.
bunch of pilots. It's okay, where's the value and how can we plug this into our enterprise to really help us meet our goals, both saving some money, but also meeting our sustainability goals. And so that's been awesome. And just kind of building on the story, and specifically how water and climate are directly related, and the need for new technologies to help us achieve full treatment, reuse, and climate goals. Um, that's what brought us to the Earthshot.
Awesome. In the period of time that I've known you, I first of all, I agree. It's an incredibly strong team, and not just with respect to strategy, but the ability to execute. And my observation is what you've done is an excellent job in integrating these issues. It's not, you know, water value or carbon value or energy value. It's a very holistic value proposition coupled with, and I don't want to sound like I should be on your sales team, but
You're hired.
sounds great. Ready for change. But the ability to deliver not just the technology but the service,
Hmm.
and you have very happy, pleased customers that are getting this multidimensional value proposition out of the neighborhood bugs that you motivate and encourage. And I think that's really interesting. And it's, in my view, it's easy to get lost in the technology and say, "Oh, this is fabulous technology; it'll sell itself and will be great," and all that. But
No technology ever sells itself.
I agree with you. Yeah, completely agree with you. It's the softer stuff, if you
Yeah.
will, that matters in the scheme of things. So, as you've been on this journey, what's your observations in terms of the challenges in the water sector, and it maybe touch a little bit on this move from centralized water and water treatment to localized, extreme decentralized systems, and just that sort of tension in the marketplace, if you will. So,
Yeah.
what are other challenges that you're seeing from your perspective?
Challenges in the water industry. Well, we don't have enough
It,
time.
No, no, no. We blocked out hours, Orianna, so we're
Okay.
good.
All right, here we go. Um, well, I'll highlight the as you say, right, the importance of central and decentralized approaches, right, to managing water. Um, so occasionally I give a lecture in School of Public Health at San Diego State University, and it's a global health program, and often students are not aware of um, modern sanitation and how it really is an anchor of our public health system. And so, you know, to start to start way back, in the cholera outbreak in the 1800s in London, um, that really is what spurred a modern sanitation as we know it, and that's what drove these centralized systems because it was very important. It was an understanding in that outbreak that it was related to water and particularly water being contaminated by cesspools that are in these urban neighborhoods. And so you needed to separate your water distribution from your sanitation management, and you
Mhm.
need to get it away from people, right? And so that led us to our modern sewer systems, and then moving our waste away from where it's generated and processing it in a centralized facility. And so, you know, if you look at, how our cities have evolved over time, it's all it's there's a lot of infrastructure that goes into making this happen. And thankfully it's there, right? But it's it's trillions of dollars in the United States to maintain. Uh, and in the
Right,
US, we only really have 75% coverage of population to sewer system. And so, there's still 25% of the US that is not connected. And, as I grew up and several others in this country, and you don't think about it in the United States, but it's very true, right? You may not have an indoor toilet. and and so there has to be a decentralized approach that can enable access to safe sanitation management and industrial wastewater treatment, which is more cost effective, to complement our existing infrastructure. Because if you
mhm,
think about, it's just it's not cost effective to try and sewer everybody, and it's completely impractical to even consider that in many areas of the world. And so, there needs to be some alternatives to complement, and that's really what we're after. So, just like we've done as a community in the energy sector, where you're looking at microgrids and decentralized approaches, which gives us more energy security in the long run and overall more cost-effective access to electricity. Uh, I think we got to do the same thing in water, and it's starting to move in that direction because
mhm.
the reality is you just can't sustain and continue to grow the infrastructure the way that we have been. But it's important that you have adequate, right, treatment and sanitation on site. And so whatever you do locally most certainly has to meet the same quality metrics,
Right.
as anything else that we're using today.
I really agree with your take that, we now have a menu of options. It's really just not last century infrastructure.
Yeah.
And, we do have technologies and business models, available, what you're doing with Aquacycl that has the ability to increase coverage and be more sustainable and resilient going forward in a world that's radically changing
Yeah.
rather quickly. So, you know, where do you see all this going? Are we going to look like the power sector or something different, or who knows?
I mean, that would be great if we can make those leaps. I think, but it is going to be a leap, right? It's kind of jumping off the cliff from what
Yeah,
folks are used to doing now, right? Um, and it's not just because of a technology. It's not at all a technology issue. I would argue. I would argue that it's a funding issue, and there needs to be incentives for our municipal infrastructure to decentralize and to enable some decentralized complementary opportunities within. their service areas. And right now there's not a lot of incentives. I mean, there are some great you know um, case studies that you can point to where it's worked really well. Um, but now you got to take those case studies and multiply them, right? And really
Right.
get policymakers on board, ratepayers on board, industries on board, public-private sector cooperation, and as you say a lot, these catalytic communities, right? To
Yeah.
really enact that change. That okay, yes, we're going to take a leap, but we're all going to do this together. And there's a bunch of parachutes that are going to keep us from smacking on the bottom. And so, let's do this because ultimately, right, that's what it's going to take to shift into that direction where the energy sector has successfully gone.
I agree. That was well put. And thanks to the raising catalytic communities, I really believe. And I refer to you as an unreasonable person, a troublemaker. In
Absolutely.
the beginning, I think we need to mobilize and challenge the status quo and get us to a better place quickly. Oriana, thanks so much. Always enjoyed the conversation, and very sincerely impressed with what you and the team have done. I want to say it seems like a relatively short period of time to me, but it sounds like it's been 20 years for you. So,
Yeah. Commercially 7.
okay, onward. So, a million thanks for being part of this, and keep doing what you're doing.
My pleasure. Well, always, always a wonderful time to talk to you. Thank you.
Good to see you.
You too.